This video is going to be about some of the finer points of knots. When we build our rope rescue system, everything is only as strong as its weakest link. A lot of times it's going to be our knot, so it's something that we want to make sure we get right. Some qualities that we look for in a good knot: they should be easy to tie, easy to untie, easy to identify and inspect. There should be minimal strength loss, and they should not be able to come untied by themselves. Another thing with knots is we want to understand the proper terminology. We tend to use the term knot as an all-inclusive term that means anytime a rope is tied. In reality, the proper term for that would be a tie. Anytime a rope is manipulated or deviated from a straight line in order to perform a certain purpose, that would be known as a tie. Whereas a knot is actually a specific type of tie where a bight or a loop is formed in the rope to attach around an object. Figure eight on a bight and a bowline would be examples of a tie. A knot. A hitch, on the other hand, is when the body of the tie actually goes around the object to attach it to it. So a clove hitch would be an example of a hitch. You can see the actual body of the tie is wrapped around the object. That creates a hitch. Bend is any time that two ends of a rope are joined together. Beckett bend. We use the term water knot a lot when we're tying two ends of a piece of webbing together. It's also commonly known as a ring bend, which would be a more appropriate term. Probably the most appropriate term for that would be an overhand bend, because you create an overhand knot and then retracing it to join the two ends together, forming a bend. We tie our different knots. We want them to be neat, compact. Rope is a valuable resource. It's a limited resource, especially when we start getting into bigger incidents, dealing with high lines, tower rescues, things like that. We want to be able to conserve rope. So we want to keep our knots compact, small. The bites should be just big enough to attach to the object that they're going to be attached to, usually a carabiner. A lot of times we're taught to do overhand or double overhand safeties to back up our knots. It's usually not necessary with most knots. Figure eight on a bight being one of those that does not need a safety. It's a self-tensioning knot, self-constricting. It's only going to get tighter as it's loaded. It's not going to slip if it's properly tied. We do want to make sure we have at least a hand width of tail coming out of the knot. There is no need to back it up with a safety. When we talk about the strengths of knots, figure eight on a bight reduces the rope strength by about 15 to 20%. We add an overhand safety into that. An overhand knot reduces the rope by about 50%. So why would we want to back up a knot with a weaker knot? It doesn't make any sense. The only time we have to back up a knot is if we have a knot that may possibly come untied on its own. Example of that would be the bowline, which when it's tensioned is a very secure knot. It's not going to come untied as long as it's under tension. But when it's not under tension, with vibration, it can actually untie itself. So bowline is one that, if there's a chance that it's going to be left untensioned, it should be backed up. There's a couple of different ways to do that. The way that's taught at the Fire Academy and a lot of places is once you tie your bowline, take that tail, then tie an overhand safety around the bight of the knot, which works for its intended purpose. It does keep it from untying itself. But again, we're backing up a knot with a weaker knot. The bowline will reduce rope strength by about 25 to 30%. Overhand safety is going to weaken it by 50%. Another way, and probably a better way, of putting a safety in a bowline is called the Yosemite tie-off. The Yosemite tie-off is just going to take the tail of the knot, and you're going to follow this loop as it bends around. You're just going to continue to follow along that line and back through where the standing end of the rope passes through the body of the knot. Alright? So not only does that create a safety that will keep it from loosening itself, but it also makes that knot about 7% stronger. Makes it to where it's virtually the same strength as a figure eight on a bight. The reason for that is, in an undamaged rope and a properly tied knot, overloaded rope is almost always going to fail right with the standing end of the rope and is the body of the knot. And this is why some knots are stronger than others. With a regular bowline, you see the body of the knot is wrapped around that single strand of the standing end of the rope. So as that knot is tensioned, this is going to cinch down, it's going to create compression and a pinch point right there. By doing the Yosemite tie-off and bringing that second strand of rope down through there, now as that's tension, that load is going to be distributed amongst those two strands instead of just creating that pinch point on the one strand, so it makes the knot stronger. Some other cases where a knot would have to be backed up, clove hitch, generally, if it's not under tension, can loosen itself, should be backed up with an overhand safety. Clove hitch is not something we typically use as a life safety knot anyway, more of a utility knot. Some other situations are if we're using Spectra or Kevlar rope, which tend to be very stiff and very slick, not a lot of friction, they also require backup knots. We don't really use those particular rope fibers in rope rescue. We do use them often in emergency escape packs for firefighters. Something to think about if you decide to purchase your own emergency escape pack. Look at what the rope is made out of. You may have to back up those knots.